Today is going to be 10-2, and we're going to examine evaluating limits, and we're still in the section of limits and continuity. Now, another way to calculate the limit is through analysis. So if you remember from the previous lesson, we took a look at how do we find the limit graphically. And we approached from the left, we approached from the right, and we kind of saw what it's going to do on a graph. Now, using analysis, we're essentially using values, numbers. And so in this instance, what we're actually going to use is algebra to be able to find the limit. So in its most basic form, when we are trying to evaluate the limit, all we need to do is take this value, so it says the limit as x goes to 2 of this given function here, x squared minus 4x plus 9. The idea of evaluating is we're literally just taking this 2 and plugging it in for x. Then we simplify it. Now if you go through and you simplify this function, you're going to get 5. For part B, it could be as complicated in this instance as possible, but if we take like a trig value here, like the cosine or cotangent of 3x, if I take this pi halves and I plug it in, so that means I'm taking pi halves and I'm plugging it in for x in both of these instances. Well, these multiply together, so I get pi fourths, and then this becomes cotangent of 3 pi halves. Well, the cotangent of 3 pi halves on the unit circle happens to be 0. And so 0 times pi fourths gives me 0, so the limit of this function here as x approaches pi halves is going to be 0. Now, if all limits were possible with this direct substitution, you would have seen this in a much earlier math class like Algebra 1. Now, unfortunately, it's not like super easy like that. They will get more complicated. And so that is part of the reason why we had to learn more advanced algebra techniques to evaluate those limits, which is a lot of the different things that we examined and learned in pre-calculus. So if you remember back in pre-calculus, we talked about this indeterminate case, this 0 over 0. This has meaning. Now what it implies is that our direct substitution will not be enough to evaluate, and we will have to use other algebra or what we know from trigonometry to help us evaluate the limit. So now let's look at a few examples of that. In this first instance, it says simplify this with algebra, right? So we're going to evaluate this limit, and we're going to have to use algebra to simplify this. Well, how do I know I'm going to have to use algebra to simplify it? Well, let's plug it in. If I take this -1 and I plug it in for x in all of these instances, I get 0 over 0. That's the indeterminate case. What that tells me, the mathematician, is now I have to use algebra to simplify this statement here, this function, further before I then start evaluating. In this instance, the algebra that we're going to have to use is factoring and canceling out similar factors. So I was able to factor the numerator, and so when I factored the numerator, the x plus 1s now cancel out. And so I'm only left with this x minus 4. Now I can check once again, do I plug in this -1? And so if I check again and I plug this -1, -1 minus 4, that gives me -5. And so the limit as x approaches -1 is going to be -5. Let's take a look at another one. Now in this instance here, we have a square root. Let's evaluate it and check. So if I plug in 7, what ends up happening is when we simplify this, I plugged in 7 for x, I once again get 0 over 0. So I'm going to have to use algebra to simplify this further. Now the algebra technique that we're going to use is going to be the conjugate. Now how do I know this? Why do I know that I have to use the conjugate? That is because there is a square root. Typically, when we have a square root of some fashion within our function, for limits, we're probably going to use the conjugate to be able to manipulate and simplify this function. And so if I take this square root of x minus 3, minus 2 over x minus 7. I'm going to take the conjugate of this numerator, and so the conjugate would be the square root of x minus 3 plus 2, right? All you do is you change that sign, so that becomes plus 2, and you do that top and bottom. Now I need to distribute, so multiply this times this. That gives you x minus 3, this times this times this. They cancel out. Negative 2 and positive 2 gives you that negative 4. I still have this x minus 7, and I have this statement here. Now you're probably wondering to yourself, well, why didn't you distribute the bottom? The reason is after you perform the conjugate, something's going to cancel out. So leave it as factored as possible so you can see the elements cancel out. So if I simplify the top a little further, this minus 3 and this minus 4, that becomes that x minus 7. Now these are factors. And so those factors are going to cancel out. I'm left with this 1 over square root of x minus 3 plus 2. Now evaluating, so plugging in the 7, and I simplify it, I'm going to get 1/4. So I can say the limit as x approaches 7 of this function is going to equal 1/4. So let's conclude this lesson. How do we evaluate a limit? Very simple. We just take the value and we plug it in. Now, it's not that easy, and so a few things to remember. If you get the instance in which it's 0 over 0, it means you can algebraically manipulate the function to find the limit. So 0 over 0 means the limit will exist, we just have to do other means to find it. The second thing, and this is going to be something that a lot of students forget, is that if there are radicals, typically the conjugate will be the means to simplify it. Now, a common question in some people is like, well, what if I get undefined, like 1 over 0? Well, that's undefined, and the limit will not exist. So 0 over 0 implies I can manipulate it. Okay, so this is just undefined, and it doesn't exist. This does conclude our lesson. If you have any other questions, please leave them in the comments.